just wish I had remembered, yeah. I finally ended up getting it, but still.
Yeah, you guys did great on your homework thus far. It's like you took the time to actually do it. We're real impressed with that. I was expecting people to do their homework. It's great. And then, for those of you worried about your test, remember that tests are going to affect your grade a lot less than homework.
Yeah.
It's expected that
Okay,
on
so
tests
do
you'll
you
struggle.
grade our homework, or do you just give us credit for doing it?
It depends. So, if I feel like your homework gives almost no effort, that's going to be a 0. If your homework is wrong, but it's technical reasons that I feel like I can easily explain to you, then I'm not going to dock for that.
Yeah.
But if you just give me a load of crap, it's not going to get
Right.
anything.
Okay.
So, a lot of judgment on my part to try and determine whether or not you should get credit for it. But I definitely will not give you credit for failing to do things that I have already corrected you on. So I expect your homework to improve as time goes on. But I'm not going to dock you heavily for mistakes on this homework that I haven't had a chance to look at, like every time you guys treated x divides 2 as the same thing as x divided by 2 or whatever, or x divides 2 equals blah, 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 blah. Up from here on out, when I see that, that's a no-go. So, that kind of stuff. All right, so list. What is a list? A list is an ordered, non-unique collection of objects. What do we mean? We mean that order matters in a list, and we mean that having duplicates in the list changes the list. So I think the best way to get intuition for what this means is to just look at examples. Here's an example of a list. The elements in this list are 1, 2, and 3. Here's an example of a list. How many elements are in this list? 4. There's 3, there's 2, there's a set of all integers, and there's a set 1, 2, 3.
Oh, I guess that makes sense.
Alright? Here's another list containing 3, 3, 3. 3 elements, 4 elements, 3 elements. Good? 1, 2, 3 is not the same thing as 3, 2, 1. These are different lists. Order matters. And 3, 3 is not the same thing as a list containing 3. Having duplicate elements matters. Does that make sense? So if 2 lists have the same size, then they're equal if and only if each of their corresponding elements are equal. So these 2 lists with 3 elements in it, A, B, C equals X, Y, Z, if and only if A equals X, B equals Y, and C equals Z. Does that make sense? Okay. So we're getting into what we call counting. You learned what even is, you learned what odd is. It's time to teach you how to count, right? Work your way up in the world. And one of the things that you're going to want to be able to count are lists. So a common question that we ask is, how many lists can we make that satisfy some given conditions? So let's look at an example. How many 2-element lists with the numbers 1, 2, 3, and 4 can I make? Well, I can have the list 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2, 4, 3, 4, 4. 16. That's all the possible 2-element lists I could make using the numbers 1, 2, 3, and 4. Right? Trying to give you some good intuition about how to visualize these things. There's 2 ways that I like to interpret it. I like to think for the first element, you have 4 options, 1, 2, 3, and 4. And for the second element, you have 4 options, 1, 2, 3, and 4. So you have 4 times 4 total options. That's how I think about it. But you're going to have to get comfortable with whatever appeals to your intuition as we go on. Different people like different things. Either way, does it make sense that there's 16 of these? And that all these lists are different lists? No 2 of these lists are the same? Okay, let's do another example. More abstract. How many lists with n options for the first and second element? So this one, I had 4 options for the first element and 4 options for the second element. Do you know what I mean by first and second element? What's the first element of this list? 2. What's the second element of this list? 3. That's what I mean. First element is whatever's here, and this is the second element. Let's look at this list. Its first element is 3, its second element is 2, its third element is the integers, its fourth element is the second, taking 1, 2, 3. So how many lists with n options for the first and second element can I make? I have n options to plug in here, the numbers 1 through n. And I have n options to plug in here, the numbers 1 through n. Here I had 4 options for the first element. It could be 1, 2, 3,
Okay.
or 4. And here I had the second. I had 4 options for the second element as well.
So does
It
that
could be
mean you
1,
have
2, 3,
n
4.
options for the first and n for the second?
That's exactly what I mean. So I'm saying, how many lists can I make if I have n options for the first element and n options for the second element? How many
You
possible
can make
lists can I make?
N.
N?
If n is a real number, you can't give it a certain number.
I'm saying for any number n you pick. Here we did the case where n is 4. What if I said the numbers 1 through 5?
Then it would 20.
What if I said the numbers 1 through 10? So if it's the numbers 1 through n,
N squared.
I have n squared options,
Okay.
right? So the first row, I would have n elements in this row. I would have, or n lists in this row. I would have n lists in this row. I would have n lists in this row. And I would have n rows, right? So I have n rows of n lists, or n squared in total. Good? Now, what about if I said no duplicates? Meaning, get rid of all the ones that have the repeating elements. So I get rid of this one, get rid of this one, get rid of this one, get rid of this one. Now how many do I have?
12.
12. Alright, what if this was 5 by 5? How many would I have?
20.
What if it was 6 by 6? How many would I have?
30.
What if it was n by n? How many would I have?
N times n minus
N squared minus n.
N squared minus n, or n minus 1 times n, or n squared minus n, or what did you say, n times n minus 1? Right?
Wait, minus 1?
Yeah, that's what you were doing. Here you did 4 times 3.
Minus n.
You did n. Oh, look. Distribute. Same thing. So n squared minus n, same thing as n times n minus 1, or n minus 1 times n. So that makes sense, right?
Yeah.
Now let's switch it up just a little bit. Let's say I have n options for the first element, but m options for the second. So this row has m lists, this row has m lists, this row has m lists, and I have n of those rows, right? Did I lose you on that one?
Mm-hmm.
Okay, let's do a small example. Let's say that I have 2 options for the first element in the list. So we're looking at 2 element lists. I have 2 options for the first one and 3 for the second. So my first one, I could have 1, 1, 1, 2, 1, 3, or I could have 2, 1, 2, 2, 2, 3. I have 2 options for the first element, and I have 3 options for the second element.
Okay.
I have n options for the first element,
No. Okay.
and I have m options for the second element. So each one of these rows has m lists in it. 1, 2, all the way up to m. It has m lists in it. And I have n rows. So all in all, how many lists do I have? N times n.
Um, what is that called?
What is what?
Like horizontal? They're not the same kind of list. Are they?
They're all just counting 2 element lists.
Okay.
So just looking at how to count different types of lists. Now, this example right here captures an idea that we call the multiplication principle, which is if I'm making a list and I have n options for the first element and m options for the second element, I have n times m options for lists I can make. So now we're going to do a proof of that. The proof is going to follow this exact idea right here.
So really quick, if you have up there, you can remove the repeats by doing n minus 1 times n. How do you remove any repeats with the second?
Removing repeats here, we have to know which is bigger out of n or m, and remove the smaller one. Here we only have 2 repeats,
Right.
because that's a smaller number.
Okay.
So you could say minus the minimum of n and whichever one's smaller. Here we would have minus 2, because
So-
2 is smaller out of 2.
Right, so n, in this case, when n is 2, you'd subtract 2.
In this case, n is 2, m is 3. We would have subtracted n, which was 2.
Okay.
If we want to get rid of duplicates. So, multiplication principle. Consider two element lists for which there is n choices for the first element, and for each choice of the first element there is m choices for the second element. Then the number of such lists is m times n. Kind of a mouthful, but I think with this picture you can see what it's saying. And then our proof is going to follow the idea of this picture. And this is your first introduction to what we call accounting proofs. Accounting proof. Counting proofs are difficult for students just getting into proofs to get comfortable with. Your gut when you first see these is you're going to say you didn't really prove it. You kind of just randomly said stuff and now you're saying it's proven. And it's probably going to feel that way a little bit. I don't know of a good way to get you intuitively comfortable with counting proofs. They're not like direct proofs that you're used to. And so it's one of those things that, I don't know, you just got to keep doing counting proofs, get comfortable with them, and then as time goes on, you'll see that they start to work. So we're going to do what's called a counting proof. Here's how we prove it. We say construct a chart of all possible lists such that each row in the chart contains all the lists starting with a particular element. So this row in the chart contains all the elements starting with 1, this one contains all the elements starting with 2, this contains all the elements starting with 3, etc. You with me so far? Now it doesn't necessarily have to go 1, 2, 3. It could have been n, 2, 5, 7, whatever. Never mind. If that loses you, never mind.
Is that because of different sets?
So far I didn't say in any particular order. All I said is arrange the lists so that each row in the chart, all the lists in that row start with the same element. That's all I've said. If the fact that order doesn't matter so far as losing you, then forget about it and just pay attention to the picture. So let's go over the first line one more time. Construct a chart of all possible lists such that each row in the chart, here's a row in the chart, contains all the lists starting with a particular element. This row contains all the lists starting with 1. This row contains all the lists starting with n. Next, since there are n choices for the first element, then there are n rows. Right? We're going to have 1 row for each choice of the first element. Since for each first option, there is n second options, then each row contains n lists. Does that make sense? So you take a particular option of a first element, and then there's m options for second elements. So each row is going to contain n lists. Therefore, there are n groups or n rows of n lists, and so there are n times n lists in all.
I guess that makes sense, yeah.
So if you feel like that proof's kind of weird, that's expected. It should feel kind of weird to you. That's okay. Alright, moving forward. More examples of lists. So, if we view a person's initials as a 2-element list, where we take the first letter of the first name and the first letter of the last name and we put those in a list together, then how many possible initials can we make with no repeating initials? So for example, My name is Donald Timpson, so my initials would be the list DT. Right? How many possible 2-element lists can I make like this where I don't have repeats, so I don't allow TT? So Tom Timpson's out of luck, we're not going to count him.
You can have 2.
How many lists can I make?
2.
1.
For all the possible initials.
So there's 4, and then minus repeats is 2.
Let me try this again because I'm not making. Let me start writing out some. Abe Beckett could be 1. John Doe could be 1. What are all the possible initials I could make?
With DT.
No, period. What are all the possible
Those are
initials I could
totally
make
different ones.
with the English language?
With 26 letters.
We have 26 letters, right? I have 26 options for this one, right?
Right.
And I have 26 options for this one. So how many options do I have in all?
Well, it'll be 26 times 26 minus.
26 times 26 minus 26,
Right.
or 26 times 25. When you give your answers for counting problems, do not give me big old numbers from your calculator.
So 6.
Give me 26 squared or 26 times 25.
Why?
Because it gives me insight to how you thought about it and where you might have gone wrong. If the answer is 1,564 and you wrote down 1,226,
That doesn't help.
there's no way for me to help you.
Right.
I can tell whether you got it right or wrong.
Wait,
But
so you want us to write it how?
write it, don't multiply it all out.
Just write it 26 times.
So if I said, how many initials can we make? The answer is 26 squared. 26 times 26.
Minus.
How many can we make without repeats? 26 squared minus 25 if you want. Or minus 26 if you want.
Or 26 times 5.
Or 26 times 25 if you want. Write it like this. Don't write it. Don't give me some big old number.
Nice to use it for others.
Good. All right, let's do another one of these list problems. A club has 10 members. How many ways are there to elect a president and a vice president? So I need to elect a president and a vice president.
With 10 members.
I have 10 members. We'll arbitrarily say that the one we put in this position is the president, the one we put in this position is the vice president. So how many ways can we do that? I've got 10 people in a club. How many ways can I select a president and a vice president?
Would be 10 times 10 minus the president or the vice president, right?
Yeah, 10 times 9. We have 10 options for the first person, 10 ways that we can select a president. Then once we've selected a president, there's only 9 ways that we can select a vice president.
Because there's only 10 people in the room.
Yeah, because we're in a club that only has 10 members. So,
Yeah,
there's,
what if you did the vice president first?
okay, how many ways can you elect a vice president? And then how many ways can you select a president after that? So in all, there's 90. Doesn't matter how you think about it. So the answer is 90. Or it's 10 times 9. Right? Let's do another one. How many 3-element lists can you make using the numbers 1 through 5? So in other words, lists that look like this: 111, 112, all the way up to 555. How many of those can you make?
Would that just be like,
Cute, right?
so just
5 cubed.
1 row? This should be 5 rows too, right? I mean 5 columns,
Well,
5 rows.
it doesn't matter if you put them in rows or columns or whatever.
Well, I'm saying it'll be 5 columns and 5 rows, right?
So you could view this as a 3-dimensional cube with 5 rows, 5 columns, and 5,
Right.
whatever you want to call those. That's one way you can view it. But another way you can see it is, imagine that we did this up to 5 and up to 5. Then that would have been 25, right?
Okay.
And then for each of those 25, I could append on the number 1. And then for another 25, I could append on the number 2. And for the other 25, I could append on the number 3. And so it would have been 5 times 5 times 5. You see what I'm saying?
Right.
Yeah, cubed. Cubed is exactly right. So the answer here is just 5 cubed.
Right.
Okay? Let's do another one. Another example. So once again, a club has 10 members. How many ways can we elect a president, a vice president, a secretary, and a treasurer?
Club has how many?
10 members. We need a president, a vice president.
10 times 9 times 8 times 6.
10
Wait, what? Oh, sorry.
times 9 times 8 times 6.
Sorry, 8 times 7.
What? Who agrees with that?
Me?
We're not missing something there?
You're not missing a number, am I?
Hang on.
6. 6? You want to say and times 6? Or replace the 7 with a 6?
There's president, vice president,
Yeah.
secretary, treasury.
Yeah.
Yeah, I agree with that.
That's a 4.
I would say 10.
Oh, no.
10 to the
That's not
4.
right. That's not right. Because it's a 4 element list, right?
Uh-huh.
Which means that it's that, but way bigger or something.
No, that is perfectly right.
Is that right?
Yes. You have 10 options for your president, then 9 options for your vice president, then 8 options for your secretary, then 7 options for your
I
treasurer.
was just wondering because I'm thinking I got a little confused with the cube.
And yes, that's exactly the point I want to get to. You're going to get to the point where you think something makes sense, and then you're going to psych yourself out because you think for some reason the number should have been way bigger or way smaller. That's going to happen over and over again.
Okay.
So just try to make sense of it the best you can. That was great.
Hang on.
What?
Why wouldn't I do 10 to the 4?
Because you cannot be the president, the vice president, the secretary, and the treasurer.
Okay?
That's what you're saying. You're saying I have.
What is the difference between those two lists?
So now let's say that you can hold all these offices. And it is possible for one person to hold all those offices.
And it's 10.
Then it's 10 times 10 times 10 times 10.
Because then you aren't eliminating the
Yeah,
numbers.
then you're not eliminating someone.
Mhm.
That makes sense, the difference?
Yeah.
Here when we were using numbers, we weren't eliminating. Once you used one, you can still use one again. Or just because you used one here, it doesn't mean you couldn't use one here.
Oh.
Here we're saying that if we put Jack as president, we can't put Jack as vice president as well. So if we made that 4-element list, we can't have the list Jack, 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 Jack in all 4 positions. That make sense?
Mhm.
Okay. So in general, here's 2 equations that we use to help us count really quick.
See, that's the next thing I was going to ask. Is okay.
If we allow repeats, then it's just n to the k, where k is however many elements are in your list. And n is the amount of options you have. Just like here, it was a 3-element list, 5 options for each element. 5 cubed. No repeats, you lose an option with every choice. So,
Okay, so when it says no repeats, then okay. Then that's
allow repeats, and then no repeats is like when you can't be president and vice president. Okay? And then we use this notation to help us make this calculation really quick. N sub k. It's notation for this exact formula right here. Now that minus k plus 1 might seem awkward, but it makes sense when you see an example, so just understand these are the formulas and then we'll see examples. Good?
Yeah.
You guys need to catch up for a bit?
No?
Nothing.
Well, go ahead and think.
Okay.
There's no rush.
So how did people come up with that formula? Like,
Dude, how do people come up with any formulas? They're insane.
Isn't that pretty natural? All the formulas we just came up with?
yeah, all of those ones. I'm just wondering how this one got.
This one?
Yeah.
It's just a generalization of exactly what we did here. This is a 4-element list, so we have 10 times 10 minus 1 times 10 minus 2 times 10 minus 3.
Right.
10 times 10 minus 1 times 10 minus 2 times 10 minus 4 plus 3. We only minus 3 on a 4-element list. So you
Oh,
see how
because
you minus 1 less than however many elements you have in your list, that's why there's that plus 1.
Oh, okay.
So it's really not that
Okay.
crazy of a formula.
Yeah.
It should make pretty good intuitive sense.
Yeah, I kind of don't understand that.
This one or this one?
Yeah,
Bottom?
top.
Top. Top. If you have a k element list, then the number of lists,
Okay, so the K is the N?
no, the k is how many positions it has. Here, this list, we were making 3 element lists. If you're making a k element list, and you have n options for each element, then you can make n to the k list. Here we were making 3 element lists, and we had 5 options for each element. So there was 5 cubed possible lists.
Why did I suddenly just leave that?
I
Because
don't
now I
know.
don't understand that.
Okay, let's go back to this one. 2 element lists. Case 2 element lists. There's 4 options for the first element, and 4 options for the second element. Right?
So K will always just be like the
How?
number that's between the, how many there are between the, so like for the example up
The
there.
size of the
equals
list.
3.
Case 3, case 4, case 3, case 1, case 2.
Okay.
Yeah. So that's what the K represents here.
Okay.
So what happens if you run into a situation where it needs to be, like, when you have to skip 8 for some reason? Like, if there's a job, so here, if you have a job, but that position has to be filled by 2 people. So it'd be 10 times 9 times 7 times 6. How would you make your formula?
We'll get into more complex ways of counting.
Okay.
And we'll do things like most of what you're exactly talking about. But first, let's get comfortable with basic counting. So let's do, huh?
I want to explain the non-repeats too.
Oh, the no repeats. So here's what we're saying. We're saying start at n and keep minusing 1 away and timesing until you get to n minus k plus 1.
Okay, but what?
So you'll see an example here. Here we said that the answer was 10 times 9 times 8 times 7, right? What is n in this case? N. How many options do we have?
10.
10. What is k in this case? What is 10 minus k plus 1?
6. 1.
7. 10 minus k, or 10 minus 4,
10 minus 4
is 6, plus 1 is 7.
Right.
So what this formula is saying is take 10 times 9 times 8 and keep going until you get to 7.
So technically that
10
first
times 9 times 8 times 7.
Okay.
Here was n plus k, or n minus k plus 1. 7 was. So keep multiplying until you get to n minus k plus 1. Then you can stop.
So is that first n really just n minus 0?
You can view it that way if you want. Alright, so moving on to more examples. So let's say we are selecting 5 objects from a bag of 3 items with repeats. So you select the object and then you put it back. You select the object, you put it back. So you have 3 options for what you can get the first time. You have 3 options for what you can get the second time, 3 options for what you can get the third time, 3 options for what you can get the fourth time, 3 options for what you can get the 5th time. So there's 3 to the 5 ways that you could have done this. Or there's 3 to the 5 possible lists you could have created. That's using this formula, n to the k. Let's look at another one using this formula. You select 3 objects from a bag of 5 items without repeats. So the first time you grab out an item, how many options did you have?